I'm hoping to quickly give you an overview of what Teradici is, for those who don't know, and for those of you who do, what we've been up to recently and what we've been releasing. So I'll leave a minute or two at the end in case there's any questions, otherwise we'll be able to speak at our pod later on. So Teradici's been around quite a while. We developed the PCoIP protocol, which is a high-performance protocol for separating remote workstations from client endpoints. And there are about 13 million endpoints today using PCoIP technology. We partner with big corporations like Microsoft, other cloud vendors, and on the client side with companies who make endpoint technology. So our technology is typically embedded in big vendors' technology, and we also have products of our own. We have a diversity of customers in media and entertainment, healthcare, finance, higher education, CAD/CAM, those types of applications. But we're here today talking about media and entertainment, which is one of the toughest markets for us, and that's why we love to get the requirements sorted in M&E, where we have a pretty big footprint. So the PCoIP protocol and its success in media and entertainment is all about the performance. When you have graphics artists, editors, and so on, they need to have color accurate graphics. Built to lossless is a technology we have, which means the color represented on the display is the exact color that was rendered by the graphics workstation. It's ultra secure, so we have big footprint in the federal industry where pixels are compressed from a graphics workstation using AES encryption, and they sent out to clients. And we have silicon and software encoding and decoders which make sure that this is ultra secure. It's supported on a broad range of platforms, including Microsoft Azure, other cloud vendors, ESX or KVM on site, Linux and Windows, and on the clients, a different set of clients that we can talk about in a couple of slides' time. And really easy to deploy because it's a cloud-native installation. It doesn't come with all the baggage of the big on-premises VDI-style applications, so very easy to deploy. You can just grab the agents from our website, get it up and running in literally a few minutes. So we're at a really interesting time in media and entertainment, in where with this over-the-top technology and broadcast, there's a lot of pressure on studios to develop and deliver at a much higher rate than they used to. So the studios are looking for ways to get higher efficiency out of their systems. They have production schedules that are squeezed. They're looking for higher artistic talent. They're looking to remote their workers. And in conjunction with real estate properties around the world, for whatever reason, graphic artists like to live in cool places like London, Vancouver, LA, Montreal, extremely expensive places. Why would you want a big data center sitting in those cities when you can start moving your data center to the cloud or out of the big city? So this is one of the reasons why we're seeing this transformation from local workstations into the cloud. The other big attraction, of course, for when you're sitting on Microsoft Azure is there's a big farms of compute that we'll talk about in a minute that is very attractive to augment or upgrade your on-premise servers. So we take this PCoIP protocol that I've talked about, and it's bundled in a product called Cloud Access Software. So when you see this logo in these slides, that's the Teradici Cloud Access Software, which is the embodiment of our protocol agents. There's some client components and a management plane, which we'll talk about in a couple of minutes' time. And this delivers a end-to-end solution, which is the highest performance way of doing remote computing for any use case. So this is just a journey slide of what we've seen the technology evolution. A number of years ago, in media and entertainment, artists would sit with their graphics workstations under their desks. And about 10 years ago, Teradici developed a encoder-decoder silicon chipset, which on the encoder side was on a PCIe card. You plugged it into your workstation, and you could move your workstation off into a machine room, whether it a Dell or HP or one of these workstations. And on the client side, we had a silicon decoder called Azure client, which is basically a stateless high-performance client technology. And the VFX industry in particular really adopted. We've got a huge footprint in all the major studios using the host card solution. Now skip forward a bit more recently, and of course we now have a lot going on in software where we've got virtualization of servers, we've got virtualization of graphics, and this is the next evolution of remote computing, where instead of having this one-to-one remote solution, which was effective for a number of years, you can get better aggregation, better putting your consolidation ratios by using shared servers with shared graphics. So we've got this move to private data center, but quickly we are also seeing the entire industry really interested in moving to the public cloud, and some studios are actually going even from traditional workstations directly to the public cloud, and we'll talk a bit about why in terms of not having to have that big capital expenditure, which is what's needed for especially the local machine room solution. So the old approach, this is the host card I was talking about. In a M&E environment, you had a big render farm, maybe 5,000-10,000 cores, and then the workstations, because they're an expensive resource, would be fed into the render farms overnight when graphics artists aren't working, which makes for a pretty inflexible workflow, but it was certainly better than having everybody with remote computing under their desks. But now what we can do with a multi-cloud and a cloud-based solution is, here's our cloud access software. The workstations can be decoupled from the render farm, which means you can have a pay-as-you-go workstation, choosing workstations that are based in the public cloud, that are really tailor-made for the use case, and have a render farm rather than being 5,000 or 10,000 cores that you have to manage as a studio. It can be 50 or 100,000 cores spun up on Azure, and you just pay for them when you need them, and then you shut them down at the end of your project until the next project squeeze comes along. So this is a really highly interesting way of doing production as we move forward. So what we get is this move away from capital expenditure to operational expenditure, which gives young studios a big opportunity to compete without having that big capital studio. You can get a bunch of talented artists and IT people. They can create a virtual studio, and they can just run directly off Microsoft Azure and get going out of the gate. Because you've got centralized assets now, you've got better collaboration, and of course your media is no longer around at those endpoints, those workstations under the desk, which is where your attack surface is. That's your big attack surface for security vulnerabilities. All the content is centralized, so you've got an inherently more secure way of doing your work, and that's why another pressure point on the media and entertainment industry is to get away from this distributed data place. So a couple of examples of what your architecture might look like. This is your editorial use case. You have 2 or 3 displays and your favorite editorial suite, Avid or Adobe. And with a cloud solution these days, this is a real thing happening today. You can get latency of perhaps less than 5 milliseconds with a high bandwidth on-ramp. So instead of having an on-premise with your own machine room, you can get the equivalent user experience using a public cloud resource today, which is quite phenomenal that that's come around in the last 3 or 4 years. And we have this exact system on demonstration in the Teradici pod around the corner here, so I encourage you later on, if you're interested, pop by and we can talk to you about this. Now, very similar architecture for visual effects. You know, it could be more Linux-oriented workstations in the visual effects industry, and you'll see here this Wacom tablet. So graphics artists like to use pen tablets, and that creates some particular challenges because you get a latency between the endpoint and the cloud, and that can really create friction for artists. So Teradici has some magic technology in our Zero clients that we call it local termination, which reflects the pen tablet directly up to the user in addition to sending it off the cloud. And we can work up to 20, 25 milliseconds at very high production, and we have people using it up at 30, 40 milliseconds too. So this is how many of the studios now, they've started by having separate data centers out in regions that can be located by artists in different cities, but they're also looking at how the public cloud can improve that footprint. Now I mentioned security, and I was at the CDSA summit yesterday, where security is a very hot topic in the media and entertainment industry, arguably now being called critical infrastructure. So there's a whole bunch of compliance requirements and assessments done by CDSA, MPAA, Trusted Partner Network, TPN. And the PCoIP protocol in a studio environment is certified by the studios because we're just sending pixels across that content network. So that's the only interface into your content network, are encrypted pixels. There's no access to the public internet, and so that will get your compliance requirements for a media and entertainment studio. Now, separately, you'll see that other little hop out. If a workstation also still needs public internet access, which is the case, we can have a double hop, a back-to-back PCoIP connection set up where you basically have your content network completely isolated, and you can have in a DMZ a virtual machine that will go out and access the internet so that no outside access can come right into the content network, which is in the red box. That's the air gap that we talk about. This is the M&E example. Of course, in federal and other industries, we have a similar architecture. So, summary of the types of architectures. We have virtualized, hypervisor-based on-premise solution, Windows or Linux, KVM or ESX type, one-to-one, so you could still have a back-racked physical workstation dedicated with maybe some high-performance, difficult use case, and then public cloud, which is what we're showing here, so Windows or Linux on the public cloud. And then a range of endpoints. I mentioned the Zero client, which is our silicon-based stateless client, but also Windows or Linux software clients, and mobile devices typically for secondary access, iOS or Android. Now, of course, you've got this great protocol, but you need to manage it. So you can use third-party tools. We have an API if you want to use a third-party management, but Teradici has a product called Cloud Access Manager. It's a feature within our Cloud Access software subscription, so it comes as part of the subscription. And what this does is it pushes out these connector modules, so small appliances that can be deployed into your environment, which do the provisioning and management of your user interfaces. So I've got a couple of architecture slides that you can see how this would work. But this allows you to, especially when you're managing public cloud resources and you want to operate in this OpEx mode, to switch your machines on and off at a local administrator level so that you're keeping your costs at an absolute minimum. So you can have a very expensive workstation for a few hours and then you turn it off when you're done, and you don't incur costs when you're not using it. So we'll start a build-up of a couple of architectures so you get the idea here. On-premise, your local machine room, few remote workstations. We have a Cloud Access connector which does the provisioning and the connection management between users and the remote workstations. Multi-factor authentication to your AD and your radius-based authentication regime. So simple way of connecting, and you could set up a system like this very quickly. Now, the Cloud Access connector also includes a security gateway feature, so you can now have external users coming into your facility, and we have the firewall in place to make sure that you get secure access into your local facility. Now let's extend it. Let's say you have a few contractors in and you're needing to quickly get some workstations going. Well, what you can do is have a VPN into Azure, and you can start instantiating these graphics workstations in the cloud in a region close to you. And not only can you use it for your local users, you can also go and have remote users in any region. So now you can start getting international on users in any region plugging into workstations in their local cloud as close as possible. That way you get the latency as low as possible, and you get this fantastic architecture. So that's this is actually an architecture that Teradici uses today for our everyday use. Now what happens is the more practical implementation these days is people still have their local workstations. They're not going to throw them out, right? They're expensive. So we're still looking to recuperate our capital cost on our local workstation. So there's a local environment, but with on-premises connection management. But as we grow, or as we're wanting to upgrade our machines, or as we add burst capability, all these reasons I've talked about, you can start augmenting these local environment with a cloud-based environment. And that's what we call the multi-cloud solution. So although it's called Cloud Access Software, it's a fully multi-cloud on-premises and or public cloud solution. all managed by the Cloud Access Manager. This is just a quick schematic of what the management interface would be. So a pane of glass that allows you to do connection management, provisioning, and power management of each of these machines, and user management as well. So Cloud Access software, bunch of features, multi-monitor. We've talked about graphics use cases, but of course there's many applications where you just want standard non-graphics, so that's obviously supported too. All the different types of endpoints, and of course licensing. Some easy way of doing it is we have a cloud licensing model, so the workstation will go out and get itself licensed. But in many markets, we need to be offline for licensing, so we have an offline licensing server as an alternative option. So we either have on-premise licensing or cloud-based licensing. And the top one there is about 4K. So most desktops today are still using HD, single or dual HD displays. And of course, as Netflix and content providers are driving to 4K, there's a quick change from desktops moving to 4K as well, and the content moving to 4K, and the whole workflow moving to 4K. Now, for a company that does encoding, that puts a lot of pressure on us to make sure that the user experience for a 4K display is the same as it is for HD. And of course, you've got 4 times as many pixels changing at a very high frame rate. So over the last number of years, Teradici has been working to enhance our protocol to support 4K. And last week, we announced an enhancement to our protocol called PCoIP Ultra. It's getting a lot of excitement in the press. If I look back to when we started out with a small software, SSE2 was like an HD 30 frame rate experience. We moved it to a sort of quasi multi-threaded environment a number of years ago, but we've now moved to AVX2, which is the Intel instruction set to port highly parallel encoding that we're leveraging, which means we can use these really parallelized CPUs in the cloud and make sure our footprint is as small as possible so that the big workflows that you're wanting to put on top of that can use most of the CPU, and that our encoding doesn't take command of it. We also announced a third-party codec support inside of PCoIP, which what that does is allows third-party codecs such as NVIDIA Quadro NVENC to be used as an offload encoding using the GPU, and we demonstrated that in conjunction with NVIDIA at the GTC show a couple of weeks ago. All this towards getting a high frame rate and build to lossless experience. So we're still looking to maintain all the quality and the security benefits that PCoIP has, but we're now enhancing it to make sure that when you're sitting down in front of a 4K display, and we have a 4K display here, you can see the performance is fantastic. And expanding this codec so that you can either support AVX2 or the offload encoding, as I mentioned. So we have a couple of case studies I encourage you to go check out on our website. This one's Jellyfish Pictures. They're based out of London, and in fact last year we were presenting with them. They are using Microsoft Azure in conjunction with our remote workstation card, and they have this multi-cloud environment. So we have a case study written up about them. Also, in terms of a purely virtualized solution, Double Negative is another one to go look at, where they basically have built out a new studio in Montreal in a number of months, and you can go find out more about them. So visit our website. We also have a trial there, and you can grab it and try it out for yourselves. Thank you very much for your time.